Hello, everyone. I'm Matt from ZK Consulting and Support Team. You may have had occasion to interact with me either on our support platform or in other actions. Welcome to this training regarding responsive design in ZK. Let's just get started. Okay, so first, a short overview of what we're going to be talking today. We're going to talk about responsive design, which has two general aspects, fluid and adaptive design. We're going to quickly touch on designing a page that is usable regardless of the device or the sizes at which the user is currently using that page. We're going to go in detail on fluid and responsive design, and then depending on time, we're going to talk about client and server responsiveness, why they're different and where they're best applied. And we may also be touching on a real-world example on how to build a templated grid with responsive behavior to make it usable on any screen size. And then at the end, we're going to take a little bit of time to do a Q&A session. If you have questions during the talk, feel free to ask them. If I think it's relevant to answer them at the moment, I'll be trying to respond immediately. And if it's more general, I'll be keeping them for the Q&A at the end. All right. So first, let's get started. What is responsiveness? What is fluid? And what is adaptive design? I'm going to start by showing you a non-ZK example. This is a pure HTML page with a little bit of responsiveness added to it to just introduce the concept of fluidity and the concept of adaptiveness. A fluid design, in essence, is a design in which the different elements that compose the design do not change their relationship with each other, but may change their size or may change their appearance to better fit specific responsive sizes. So for example, you can see I have a design here with 3 children, child 1, 2, and 3. When my window becomes bigger, up to a certain point, those elements become bigger. And then after a certain point, they stop growing. That would be an example of fluidity. On the other hand, on the bottom of the screen, you can see that I have an adaptive view. Adaptive design, for the purpose of this training, is going to refer to any design that will change the content or the structure of the page, where we're not simply changing how the same element behave, but we're changing the elements themselves entirely, or we're changing their relationship with other elements in the page. So in this case, you can see that I have two different views. I have an adaptive view 1 and adaptive view 2. If I'm on a smaller screen size, I'll be displaying this specific element. If I'm on a larger screen size, I'll be displaying this specific element. It's an abstract example. In the real world, you would use, for example, a different menu or a different control for a given task. Okay, so now that we've established this, let's talk a little bit about first fluidity. Fluid design is what I was just mentioning, is using the same elements and allowing them to change size or to wrap differently, but in a way that doesn't fundamentally change the structure of the page. We're not going to move elements around. We're not going to replace a text control by a dropdown or something like that. We're using the same building blocks, and we're just making sure that they play nice at different screen widths. In ZK, the most basic way to do this is to use ZK flexing. ZK has built-in flex capabilities where you can add a H flex or a V flex, horizontal flexing and vertical flexing respectively, to different ZK component, which will inform how those components are meant to size in comparison to each other when the page size either increase or is reduced. We're going to go directly to a code example regarding this. So for example, in this case, I'm using in this layout, different menu items, which are just divs with extra properties. They're not actually ZK menu items. They're just here as a placeholder. And on those, if you look at those two children here, for example, this one has hflex1, and this one has hflex2. Those flexing information tell those components what their relationships with each other are. And that means that this component with hflex2 will always be twice the size as this component which has hflex1. In another way to phrase it, this component will use 1/3 of the available widths, and this component will use 2/3 of the available widths. If we see that in action, you can see here that I have my two components, my menu item 1 and my menu item 2. Whenever the width of my page is updated, you can see that those elements always maintain those relative widths with each other. Menu item 1 is always 1/3 of the page width. Menu item 2 is always 2/3 of the page width. And so with these basic building blocks, we can create in ZK a UI that will hopefully avoid throwing scroll bars everywhere all the time when you're changing the different responsive steps. You can control, for example, if you want an element to have a fixed width and the other one to consume the rest of the available widths, we could tell our component here to use a fixed width instead, and then have our flexing component consume the rest of the page. There's many possibilities. It depends on what you're trying to design for. And this is, as I say, the first building block. The second building block is flexing with CSS Flex. This is similar to using ZK flexing. And in fact, from ZK9 and later, ZK flexing internally relies on CSS Flexbox. And CSS flexing is technically something you can do in ZK, but it's not a feature of ZK. It's more due to the fact that ZK renders in a web context, in a web page, and all web page support CSS Flex, which means that ZK also support CSS Flex. This can be done without ZK. So for a very simple example here, I'm using, as you can see, a JSP page. So essentially just an HTML file, just to demonstrate that this is not a ZK dependent feature. That's something you can do in ZK, but is not reliant on ZK itself. You can see here that I'm using a CSS rule, which is display flex, which means that the element inside of my flexbox which have a flex rule will flex in relation to each other. So if I go to this specific code sample, don't think I have it open. Let me just, there we go. If I go to this code sample, you can see here, I have my 3 elements, and they're doing something very similar to the ZK flexing that I was showing you before. They all have their flexing relationship. This one is always consuming twice as the second one, and the third one is not flexing. The third one maintains the same width all the time. So yeah, essentially the same concept, but you can do it with pure CSS as well. Both the shorthand in ZK and doing it with your own CSS code are valid. They have slightly different application, but it's a topic for a more advanced discussion. So we're going to go quickly over that for today because we have more in-depth things to talk about later. Okay. What that means, since ZK is compatible with CSS Flex and with just CSS sizing in general, is you can also achieve client-side responsiveness with responsive providers. And a good example of that is Bootstrap Grid. If you're not familiar with Bootstrap, Bootstrap is a client-side framework which provide a number of different client-side solutions. I'm not going to go over everything that Bootstrap does because Bootstrap does a lot of things. But one of the things is Bootstrap has a system which is called the Bootstrap Grid system, which is modular. It can be used by itself without using the rest of Bootstrap. And what it does is it lets you divide your screen into responsive columns, and it lets you assign sizes in terms of number of columns, which you want to assign to your different display element. So what does this look without ZK? Without ZK, it looks a little bit like this. You will have your Bootstrap columns. Do you have? Okay. Oh, I already have it open here. Okay. You have your different elements with Bootstrap columns, and you tell your Bootstrap provider, I want this element to use 3 columns when I am using a medium screen, so column medium 3. But I want this element to use 12 column, which is to say the entire width of the screen when I am on a small screen. In practice, sorry about that. In practice, this is going to look a little bit like this. Where's my sample? There we go. There we go. So you have here your 3 elements, your menu item 1, 2, and 3. You can see that currently they're using the medium screen size, where each of those items are using respectively 3 of the columns, so 1/4, 6 of the columns, so half, and then 3 of the columns again, so 1/4 again. And when I reduce the screen size to the point where it becomes a small screen, extra small, you can see here that all of my columns now, all of my elements consume 12 columns each. So they have been resized in such a way that they all consume a single row. And from there, you can easily swap between those 2 presentation styles. It's not changing the relationship to these elements from each element to the next. Menu item 1 is still a child of the row. Menu item 2 is still a child of the row, etc. They're still in the same order, but they have slightly different presentation settings applied to them. Okay, so skipping to how to use that in ZK. In ZK, we can actually just simply import the same system by simply applying the Bootstrap system to a ZK page, either locally using just a link like I'm using in this page, or globally by using language definition to load Bootstrap on an entire project, for example. And using the S class in ZK component, we can actually simply add classes to the rendered element used by ZK. So in this case, I have a structure that uses ZK components in which I can add more ZK component. I can add text boxes, ZK controls, any sort of things that are controlled by ZK. But the sizing of that layout is controlled by the Bootstrap grid system. So for example, here I have my box content for my headers 1, 2, and 3, which use similar rules to the one that I've been presenting on this sample. So let me go to that one as well. There we go. You can see here I have all of my row using the column, the 12 column, because we're on a smaller screen. But if I expand my screen a little bit, we switch to the medium display, at which point all of my columns now use the medium display. So you can see this one is now using 6 and 6. This row is using the entire width of the screen. This row, header 1, is using 12 column, so it's using the entire content. And then header 2 and 3 below are using 6 column each, so half and half. And this way we can delegate handling the different responsive size for our layout just to the client side without doing anything in ZK specifically, just by using the fact that ZK itself is built on CSS. You can add those classes to essentially anything. You may want to be mindful that some ZK component include their own sizing. So for ZK component that use their own sizing internally, for example, like a list box, you may want to make that list box hdflex1 inside of a div that have a bootstrap base column. So you're rendering the container using bootstrap, and then you're putting a flexing ZK element using ZK flex inside of it. That's only for really complex element. For anything that is somewhat simple, just putting the S class on it is going to work in my experience. So yeah, you just try it out, and more time than not, it's going to just work with the S class. And if it doesn't, you can just put the ZK flex on it. Okay, so we've been talking about flexing. Flexing is interesting. It's the simpler way to achieve a design which does not break regardless of the size of the screen that you apply it on. So now let's go ahead and talk about adaptive design, which is a little bit complicated, a little bit more complicated. So adaptive design at its core is the concept of replacing entire structures or moving structure around when detecting different screen sizes. The idea here is that not every page structure is applicable to every single viewing experience. Let's say you have a very wide screen, for example. On a very wide screen, you could display a large grid with a lot of columns, and it would be usable because the user can see all of the columns at the same time. They can easily relate vertically and horizontally which row contain which value for which column, no problem. But if you try to do this sort of grid on a smaller screen or even on a mobile device, you might get in a situation where if you have 20 columns, when they're trying to go and see what's on the right side, they're no longer seeing the first column, so they're losing track of which column they're on. And you might be trying to display more results that are currently displayable on one screen. So going to have a vertical scroll bar, you're going to have an horizontal scroll bar. It gets difficult to use. So in that case, it can be a good idea to simply have different display solution for different devices. You can have an experience that is geared primarily to desktop user, and have an experience that is geared primarily to mobile user. Or you may have something in between where you're progressively removing widescreen feature and transforming them into mobile device features as the screen size reduces. How do we do this in ZK? ZK have multiple options. First is the ClientInfo event. The ClientInfo event is mostly useful for MVC-based application because it gives the developer control over what they want to render depending on the result of an event. The ClientInfo event is sent to the server by the client once the page has been displayed, and it contains information about the device. Information which contain, for example, the device width, the device orientation, whether it's on portrait mode or landscape mode. It can contain the pixel ratio. It contains a lot of other things, just those for width, height, pixel ratio, orientation are usually the most useful ones. And based on that information, as a developer in your composer, you can simply decide to do different things. Let's see how that might work. Okay, so if we go to our ClientInfo event page here, we will see that we have a simple page which has an empty content. That empty content can be filled with different layouts depending on the device detection. So we can go to our responsive composer here, and we can see in our responsive composer that we're binding the ClientInfo event to an event listener in our component. That ClientInfo event triggers when the page is loaded. It also triggers whenever the page dimensions changes. So if the page is resized on a desktop browser, for example, or when the device information changes. So if you're using a mobile device, if the orientation of the device is changed, the client info event is sent again. And because we are able to retrieve information from the client info event, we can do programmatically different things with our page depending on the layout. So for example, here, this is a very simple example. Of course, you can go into way more complicated decision chains here, but here we're only checking for desktop widths. And we try to check whether or not the desktop width is bigger or smaller than 1,200 pixels. If the size is bigger or equal to 1,200 pixels, we're going to display the big layout. And if it's smaller than this value, we're going to display the small layout. I am aware that a simple else would have been enough here. But this is just to visually represent the two different categories in which we're going to be. Don't worry about it. Okay, so what are we doing? In the big layout, we're going to create a list box, and we're going to display our model data with a list box. And then we're adding that list box to the page. And if we're in the small layout, instead of doing a list box, which would be harder to use on a mobile device or a smaller layout, we're going to use a radio group instead. And our components, both the list model and the radio group, this is important, are using the same model object. And that model object exists on the composer. It's not a function of the layout. So we're separating the data, the model object, and the display, the layout. As a result, when we go to our page here, we're going to see our MVC ClientInfo.zul, the page we were just looking right now. If we are on a screen that is smaller than 1,200 pixels, our choice option here is going to be represented by the small layout. We're going to have our radio group model, which chooses our selection model. And if we go to a bigger page size, our selection model is now used by the list box. And our list box keeps, yes, we can do an equivalent solution. This might actually be the next chapter. Give me 5 minutes, we're getting there. Okay, and so yeah, crucially, our list box here uses the same data model, the same selection model. So if I do a selection here and then I swap layout, you'll find that the same selection has been maintained because it's not dependent on which layout is being used. It's dependent on the data state that is not dependent on the layout. Okay, so let's go back. As I said, this is useful in MVC because here we are manually piloting the page. We're creating data. In this case, I'm creating components manually, but you could create components from a Zul template rather than having to create them all one by one using execution create components, for example. It really depends on what you're trying to achieve. So yeah. And for more information, we have a browser information and control page in the ZK doc that I strongly recommend you take a look at if you're interested in that topic. So now, ZK media queries. What if there was a MVVM feature in which we can do similar things? That's ZK media queries. Media queries let you use rules that are similar in syntax to CSS media queries. I'll just quickly mention CSS media queries because you might not be familiar with it. But in my introduction page, when I was swapping between my blue and my green layout, this was done using CSS media queries. A CSS media query is a rule which has conditions. And when those conditions are met, the rule is applied. When the condition is not met, the rule is discarded. So in this case, you can see that I have a rule for when the screen is 800 pixel or lower, and a rule when the screen is larger than 800 pixels. And depending on which rule is applied, one of those components is going to be display none, and the other one is going to be display block. And this is inverted in the other case. That's useful in CSS, but how do we use something similar in ZK? In ZK, we have match media. Match media, as you can see, have very similar syntax. In fact, the syntax of match media is based on the syntax of media queries. So if you're trying to find out how to write a specific rule, you should refer to how that rule would be written in CSS media queries. And what this does is we have our different method on our view model, which are annotated with match media. We have one annotated on 800 pixel, both media query is active, yes. A better way to write this, I'm going to just gloss over, would be to have a first media query active on any size, and then having an overwriting media query active on bigger size. This would be more correct in a production case, because this is a larger public demonstration case. I've made the choice to write them in a way that is not optimal, but easier to understand. But you're correct. There is more precise way to write those for an actual production case. Yes. And so here we have our match media for 1,200 pixel and higher. And we have our match media for 1,199 pixel and lower. And what happens is when ZK detects that this condition is true at client side, ZK will send a notification to the server and will trigger this method. This method is changing a property of the view model and is also notifying that property, which means that any Zool data binding that relies on the layered state property will be updated whenever one of those conditions is being triggered. So what does that look in practice? In practice, let's see. We're currently in this one, our shadow elements. Oh yeah, I should probably introduce how that works in Zool as well. In Zool, very simply, because we're changing our templates based on the value of the view model layout state. View model layout state, as we just saw, which is modified whenever the media query triggers. So layout state is small layout under 1,200, and is big layout over 1,200 pixel of screen width. If we are, can I go back to my MVVM shadow? Yep. If we are currently in a state where vm.layout state is big layout, we're displaying a list box which uses the VM selection model. And if we are currently in a state where the value is small layout, we're using a radio group which uses the same data model. And it's the same thing as the previous example. Because the selection state is not a function of the template, but is a property of the view model itself, we can swap between the different responsive states. And when we swap between the different responsive states, the model state will stay the same between the different responsive states. This is very useful because you don't need to reinitialize everything, and you don't really want your data model to be dependent on whether or not you're on a mobile device, a small screen, a big screen, etc. Okay, so you can put that together with the bootstrap integration that we were mentioning in the first part, in the fluid design part. So I was mentioning earlier that you could integrate your bootstrap CSS, your bootstrap grid, into essentially arbitrary ZK pages and use those elements to size and organize your client-side objects without having to use ZK-specific CSS on them. So how does that work? I have here a layout which contains a container. So that's my main div for my page. Inside of my container, I have a row, which is a bootstrap grid defined class, which indicates that everything inside of that object is going to organize itself using the row feature of bootstrap grid. And inside of that row, I will create elements that use the column grid system. So in that case, I'm going to organize my radio when I'm in radio mode using medium column 4. So 1/3 of the available space when I'm on a medium screen. Small column 6, which is to say half of the available space when I'm on a small screen, and extra small column 12, which is to say all of the available space per radio element when I'm on an extra small screen. So let's see how this behave in the actual page. Okay, so if I go way big, I'm on my big layout here. If I go a little bit smaller, I will reach the first responsive breakpoint provided by Bootstrap, at which point you can see that all of my elements here are consuming 1/3 of the available space. If I go further down, not all of my elements are consuming 1/2 of the available space, which means that since I'm using 3/2 total, 1 + 1 + 1 equals 3/2, the third element does not fit in the same row and is wrapped to the next row. And then if I go further down in size, now all of my elements are using all of the available space, and therefore they all wrap one by one. Of course, this is a smaller scale example, but you can apply those principles to size basically any sort of pages. You can do both responsive and adaptive. So as you can see, we're doing a fluid responsiveness using Bootstrap Grid until this size of screen. If we go above this size of screen, we now switch to adaptive design, in which we're actually replacing the entire component with a different component from server side. Okay, I've gone quite fast, and we're at the end of the main part of the talk. So if you have some question on this part, I think we can take a few minutes. Where are those Bootstrap breakpoint defined? That's an excellent question. If you download Bootstrap without customization, those breakpoints are defined by the Bootstrap library itself. Bootstrap assumes that 99% of the time, as a developer, you don't really care. You just want generic sizing of screen. So it just set those breakpoints for you. If you do care, you can customize your Bootstrap library. I know that in some version of the Bootstrap downloads, you can actually build the Bootstrap library yourself. But if you take a look at the Bootstrap CSS file, you'll find that the different responsive sizes are defined in there somewhere. So if we look at those breakpoints here, you will see that there is those media queries inside of the bootstrap.css. So yeah, up to you if you want to rewrite them, or if you want to use the custom downloader to create a custom version of those breakpoints, or if you want to just use the default breakpoints, which in my experience, they're good enough for most use cases. unless you have a specific need where you want to specifically stop at a given set of breakpoints. Okay. If there's no other specific question for this part of the talk, I'm going to switch to the a little bit more advanced section. So let's just get to it. Okay, so going further, number one, let's quickly talk about client-side, server-side responsiveness, and I'll also mention page responsiveness versus component responsiveness. Okay, so we've seen essentially two main way in which we activate responsiveness on a page. One way with fluid design is to keep the same elements, but just organize them slightly differently in terms of width, in terms of whether they wrap or don't wrap, this sort of thing. This, generally speaking, will happen at client side because you really don't need a server request and response cycle to know that you need to just be a little bit bigger or a little bit smaller. So in order to do this type of responsiveness, fluid responsiveness, you're going to want to use zkFlex, which happen at client side. You're going to want to use CSS Flex. You can use CSS Flex yourself by defining your own media query, your own breakpoints, or you can use a provider. So in this case, in this sample, I've used Bootstrap as a provider, but there are other responsive providers which all use CSS flexing. So whatever makes more sense for you, if you're already familiar with one of those frameworks, feel free to integrate that one. And yeah, it costs basically nothing in terms of resources because you're not sending requests and you're not doing expensive redrawings in the page. You can do a little bit of adaptiveness at client side. So I've been showing in the introduction sample here, even though this is pure client-side code, the fact that I'm using client-side responsive breakpoints, those responsive breakpoints are declared at client side in a style, so in a CSS style element. This means that those breakpoints do not require a server-side request in order to be effective. They will trigger in order. So first this one will trigger, then this one will trigger, depending on the screen size. And yeah. But most of the responsiveness that is adaptive, I've been showing you today, happen at server side, either using the ClientInfo event or the match media query. What is important to understand here is when we're using client-side adaptiveness, we are not simply making something visible or not. We're changing the structure of the page. We're removing things and we're adding other things. This is good because it keeps the page light in terms of content. If you were doing adaptiveness at client side, you would need to front load all of the elements that are possible state for your page, and then you would switch between them. By doing adaptiveness at server side, we're only ever sending whatever template is currently used by the page. And the templates that are currently not used are not created in memory. They're not using resources at server side, and they're also not adding content to the initial page response. The drawback or the cost to say about this is that because it is happening at server side, you need to have a request response cycle to send the information that the template need to be changed, and to receive the response. This is the new template to apply. This is usually not an issue if you keep the template reasonable in size, but it's something to keep in mind. You will have a little bit extra traffic, usually not a problem, but you need to consider the fact that the extra traffic will be there. Okay, the big plus, in my opinion, is because if we look at the client side for the for the first sample I was giving you. In this client-side sample, you can see that both of the elements used in the adaptive view are front-loaded. They're both existing in the DOM tree, which means a user with developer tools might be able to see different responsive templates that are technically loaded in the browser, but you're not expecting someone to go and look into. Whereas if you look at the responsiveness from server side in ZK, in this case, you can see that in my panel, I only have my radio group. And if I go to a bigger responsive size, and I display my list box instead, the radio group is removed, and you only have the select element of the list box that is in your DOM tree. So it is much more clean, and it avoids situation where you have multiple version of the same data essentially in the page at the same time. Okay. I think that's all in this one. And we still have a little bit of time before we go to Q&A. So I'd like to introduce a real world example. And I like that one because it explains why you want to make components and pages more usable for different screen size. This is an example which I call the responsive grid. So I was mentioning earlier that if you have a lot of data and you want to display that data in your page with different rows, different columns, there will be a point where if your screen becomes smaller, your column will all be squished together, and either it's going to become impossible to read the content of the columns, or you're going to have scroll bar vertically, horizontally everywhere. So what you want instead is to adapt your design using adaptive design steps to have different version of your grid for those different screen sizes. How does that work? So let's go to the code and let's introduce how that works directly in code. In the responsive grid page, I have two different templates. I have a vertical layout, which is my template for very small sizes, where I don't use a grid at all. And I have other templates. So everything that is more than 400 will use a grid with a variable number of columns, depending on the size of the screen. I'm not going to go too long into detail on the vertical layout, because the vertical layout is just using an iteration in order to just display every element in my data model. It's not very interesting. It's just basic MVVM. You don't need to worry too hard about that one. The interesting part is in the grid. So in the grid, we use two shadow elements. Shadow elements are used in ZK MVVM to display conditionally different template or different content depending on the state. So I have my view model. My view model has a view template property. And depending on that view property, I have a choose when otherwise structure. I don't have an otherwise here, but I could have an otherwise for unhandled case. The choose when otherwise might be familiar to you if you've ever used Java. There might be similar structure, let's say, in Java code where you have a condition, and depending on the value of that condition, you do a number of different things, right? It's templated on that. So, okay, when my template is between 400 and 500, I'm going to only display two columns. When my template is 500 to 600, I'm going to display the same two columns plus the age column, etc., etc. The more, the bigger my screen is, the more column I will be adding into the columns tag of my grid. And in addition to that, in my templates, you can see here that in my model binding, I have bound the @template annotation. This tells the grid that I want to use different templates for my data, depending on the value of the view template. This is done by declaring all of those templates one by one in the grid. Under 400, I don't want to have anything. This is mostly a unhandled case. So this one is not supposed to be viewable. I just put it here to avoid potential issue, but it's not necessary to be here. And then we got to the interesting one. If I am in a template between 400 and 500, so the smaller size, I have a master detail. Master detail is a box I can open, which gives me additional content in a row. And I have then a single column in addition to my details, which is my first name. If I am between 500 and 600, I remove the age element from the user details. It's no longer in the details. And I add the age element as a column in the grid. I think by now you understand the logic. So what does it look like in real life? Here I have my grid on the big screen. I can display all of my columns, no problem. But if I go and go and go smaller, when I reach the point where the size of the columns become a little bit tight and a little bit difficult to read all of the content at once, I remove some of the values from the columns. I create a detail, which is to say a box I can open as the first column, and I put in those details all of the columns that I cannot easily display at that responsive size. If I go smaller and smaller, the smaller I go, the more columns I remove, and the more columns I put as entry in my details. And if I go really small, at some point, my brother is not even letting me do that because I can't go under 400, but you have to take my word for it. Yeah, if I zoom in, that works. If I go really small, I just remove the grid entirely, and I replace my grid by just a simple CSS-based layout in which I have a much more mobile friendly, because this can be easily scrolled by the user on a touch device, and with big buttons that the user can use instead of trying to do the actions with, for example, a click on a username, which would be harder to do on a smaller size grid. Okay, I think that's about everything I wanted to mention on responsiveness for today. We have those green templates do not apply to the grid header in the column section. You use a slightly different way to do it. That's what I was introducing. You use the choose when otherwise, simply because the grid model template is meant to be used with the data layer, with the data template for the row rendering. For the columns, that's the purpose of using choose when otherwise. You can use a similar pattern. The thing is, the columns value and the template value could be made into a same iterator. In this case, I'm using an iterator. I'm just creating those columns manually. You could have, instead of that, you could have a for each element that iterate over the different column that exist in your columns model. Instead of swapping template, you could swap a columns model. That would be a more advanced way to do this. It would be very interesting to do. And it's actually a good illustration that there is no perfect responsiveness design that you can apply to every use case. But there are design solutions you can create and apply to different responsive requirements. Yes. Yes, so I was saying samples for this talk are available in GitHub. Documentation has received an update on our developer reference documentation, which contains in-depth explanation of everything I've been displaying today, and uses the same example. You will be able to download this presentation at the end of the talk after it's been made available online. And the sources for the example are in our GitHub ZK Books project. Okay, let's go to a bit of a Q&A. I hope that was interesting. If you have any questions, anything you'd like to discuss so far, let me know. Yeah, if there's no question, actually, I'd like to talk more about the grid header thing with for each, because it's an interesting topic. It's really a good illustration. As I was saying, there's no one size fit all solution for responsiveness. It is responsive design. You need to understand the requirements, what you're trying to achieve. And then I hope I've given you an overview of different tools that you can apply to get the page to behave in a way that makes it usable for the different screen size that you want to support. Okay, thank you for the kind words. Okay, what's new about responsive solution in the next ZK 10? I don't think there is a lot of changes in ZK 10 compared to ZK 9. ZK 9 has introduced a lot of those responsive tools, especially using shadow element, using match media, using all of the MVVM support for responsiveness is already available in ZK 9. So good news, those tools are already well tested, well working. There's absolutely no issue about me recommending them. If you're already on ZK9, you can just get started immediately without the update. We have some plans in the future. This is currently in it's not been implemented yet, but we are thinking of adding extended support for responsive states. In the current example I've been giving, using the MVVM templates here, as per the previous example, those responsive states are user-defined. They are part of the responsive template view model. So you have those media queries. They are giving you different view templates for the different sizes. One thing we would like to do in the future is to skip having to do that. Instead, you would just say, this is my template on a small screen, on a big screen, on a medium screen, on a very big screen. And then you just define those sizes once. And then you have all of those sizes already preloaded for your entire application. As I said, it's in planning. I don't know when it's going to be out. So don't consider this for your current responsive design needs. It's just one of the plans we have for the future of responsive design in ZK. Okay. We still have about 5 minutes. If there's any more question, feel free to ask them now. Otherwise, if you don't have further question, for everyone else who want to stop here, I'm just going to say thank you for joining the presentation. I hope this was interesting, and I hope you learned something. And I hope this is going to be useful for adding responsiveness to your applications and projects. Okay, I'm going to give until the hour, so 4 more minutes if you have question to ask, and if you don't have, feel free to just get out here. And very happy to see you. Thank you, everyone. If you have a question and you just need a little bit more time to type, just say, I have a question, and I'll keep the clock running. Otherwise, we will probably cut it soon. Not a question, but a tip. Please let people put their chat to the audience, not just you. I think everyone is already enabled. I might be wrong, but I think you're already chatting to everyone currently. Am I incorrect? You did. Okay. Was that what you were talking about, or am I misunderstanding your question? Um, I am not sure. I see some people are using direct messages. I see some people are using everyone. Okay. Stack up and shadow technique working in a latest version. What are we talking about? ZK Stackup, JavaScript variable to handle stackup and auto hide technique. I don't know. That's a fairly old technique. I think that's ZK probably, yeah, that's ZK3. Um, I'll be entirely honest with you. This is from ZK3. I've never used this, even though even though I'm ostensibly supposed to know everything. In fact, do not. In this case, I've never used that feature before. I don't know. Usually ZK is pretty good at keeping um, legacy features working. I wouldn't be able to tell right now. I'd have to test that. If you want us to do a test and come back to you, feel free to send us a message on our info mailbox, and I'll have to do that at a different point in time and come back to you by email if that's all right. I don't want to give you incorrect information because right now I just don't know. Okay. We're getting close to the hour. 30 seconds. If you still have questions to ask, it's your time. Otherwise, we're going to shut down shortly. In the meantime, thank you everyone again for being here. And hopefully see you in a future training. Hope you had a good time, and goodbye, everyone.